Let's see, I have this going on. I'm going to start by pointing out that our most precious gift is our love for God. And it gives, our knowledge of God gives us a life both meaning and purpose. Yet these days, because of society, our religion is often under attack. And especially for young people, having the criticism often results in their losing their faith. Also because of social pressures, professors at the universities. And so it's important that they have their faith be grounded solidly and be prepared to respond to criticisms in a logical and effective way. If they've thought about the problem, it's easier to be able to respond. And one of the criticisms comes from science. Often it's thought that science and religion are in conflict. And in fact, I want to point out that they're not. They actually complement each other. Now, it's true that as Catholics, we are required to accept a lot in faith. And there's much about our faith that cannot be addressed in science. Three persons in one God, I accept it, but there's no way that science can deal with that. But there are other aspects where science does complement our faith. And I think about faith as a tree, and if it has solid roots, and science can be a fertilizer that helps the roots become strong, and the tree produces more fruit. And we need to produce fruit. That's one of the things we're called to do as Christians and Catholics. So with that as an introduction, I always have difficulty with introductions. So I need to keep notes. I want to address why I'm saying that science rediscovers what God has revealed. And I want to go back in time about 100 years or so. I'm not going to go farther back, where scientists thought they really understood just about everything about nature, and there were surprises. Way back, you probably know about Newton, Isaac Newton, in the context of gravity. But he contributed to science in a variety of ways, and in fact, his book, Principia, was a Bible, basically, to the scientists for centuries. And in that, the assertion was that the universe was constant. It was always there. Now, even though many scientists were Christians and they believed in creation, they thought as well, once the universe is created, it's just there permanently. And even Albert Einstein in the 20th century took that as a given. In fact, his theories were consistent with the universe having a beginning, but he actually fudged his mathematics to make it seem like it was permanent. And he refers to that as one of his greatest blunders. But think about being a person or a scientist 100 years ago or so, and then reading Genesis, rereading Genesis. And you look at Genesis, and it says, right at the beginning, it says, then God said, let there be light. And this was on the first day. Of course, there weren't days, there were periods of time. But then you think about the universe being always constant, and you say, well, there's nothing there, and now God makes light. Now we know from their experience that light comes from the sun, from the moon, from the stars, candles, fire, but the candles and fires and light bulbs use energy that comes from the sun or some leftover energy from the formation of the Earth. If there's no Earth, there's no sun, no stars, how can there be light? So the natural conclusion is to say, well, maybe this is just poetry. You know, God didn't really mean that. Well, now we know that that's not true. That the universe had a beginning. And by the way, when God said, let there be light, he's probably referring to energy. One of the beautiful things about the story of creation in Genesis is that it applies both to primitive people that don't have any knowledge, and also speaks to us today with all our scientific knowledge. And it's very hard to write anything that can address very different audiences. As a scientist, I often address audiences with very different backgrounds. It's very difficult to be able to pitch your talk to people at different backgrounds at the same time. You may bore some and lose other people. But Genesis really speaks to us all. In fact, one of the things that, I should go back here again, it also says is that in the first day, God separated light from darkness. And obviously you can think about day and night, but of course day and night can't exist when the sun is not present, right? So how can that be? Well, I'll come back to that a little later and show that our understanding of how the universe came about explains that statement. So I'll get to that a little later. The person who first proposed that the universe at the beginning was a priest was Georges Lemaitre. He was a doctor of science at Catholic University in Louvain, Belgium. He actually became a priest later in life. He was a scientist to begin with, but at the age of 39, he went to a special seminary for late vocations and became a priest. Later on, he obtained a Doctor of Science from MIT. So he was a well-known scientist among other scientists. And his publication stating that there was a beginning was back in 1927 and was received not well at all. There's a lot of problems with the idea that the universe started at a point. What we're talking about here is basically the universe started at a point finer than the tip of a needle, and then expanded to what we have today. Now, one of the big problems is that, for example, here's a picture of a part of our Milky Way, and that Milky Way has about 1 trillion stars. And if you look at this is a deep universe picture these are all galaxies. These are not stars. These are all galaxies. And this is from the Hubble telescope, a deep image from the Hubble telescope. And in the visible universe, there are about 1 trillion galaxies. So we're talking about 1 trillion galaxies, each having about 1 trillion stars. So we have 1 trillion stars. And imagine all that matter and energy being located at a point. Now, if somebody tells you that, you say, well, you're crazy. That's not possible. But it turns out to be true. So that's just one of the problems that make scientists not believe there was a beginning. And as an example, this is a photograph of Lemaitre with Albert Einstein and with Robert Millikan, who actually was the first person to measure the charge of an electron. He's a very famous scientist. And so he hobnobbed and talked to these people. And he recalls that when Einstein heard about his theory, he talked to Lemaitre and said, I quote, "Your calculations are correct, but your physics is atrocious." Now the irony here is that the calculations were based on Einstein's own theories, and the calculations were the ones that demonstrated that there was a beginning, okay? But the scientists could not believe that, so the interpretation, the obvious interpretation from the science had to be rejected. And other scientists, for example, said, that Lemaitre's idea was a speculation run wild without a shred of evidence. In fact, there was evidence, but it was rejected. Soon thereafter, Edwin Hubble, who was the space telescope was named after, was studying galaxies and observed that the galaxies were moving away from each other. And the speed that they moved away depended on how far they were. So the obvious conclusion is that they started at some point. But even Hubble had a great difficulty coming up with that conclusion. In fact, in 1938, long after he made those observations, he still said that maybe his results are still consistent with a static universe. It was very difficult to accept. Now, the church accepted this rather eagerly. In fact, in 1951, Pope Pius XII stated, and in an address to the Pontifical Academy of Sciences, as you see there, that the following is a very good statement. Contemporary science, with one sweep back across the centuries, has succeeded in bearing witness to the august instant of the primordial fiat lux, let there be light, when, along with matter, which is not true, there was no matter at that point, there burst forth from nothing a sea of light and radiation. And then he continues by saying, the world came forth from the hands of the Creator. It's a very powerful statement, and soon thereafter, a couple of scientists named Penzias and Wilson built an antenna, a large antenna here. We can actually go, we've gone to see it in New Jersey, just walk up to it and touch it. And it was designed to measure the microwave coming from space. They were looking for something else, but they found a microwave radiation, which is the glow from the initial moment of creation. Now, it's in the microwave region. You say, well, it's low energy. That's because the expansion of the universe does not involve in having more matter. All the matter and energy was produced on day zero. What's expanding is space. Now, we think about space as being just emptiness. Well, it turns out space is something. We don't know what it is, but it's something. And energy is vibrations in space. So when you have very, very small wavelengths, the energy is very high. As space expands, the wavelengths are stretched. And so 14 billion years of expansion resulted in those very narrow wavelengths to be stretched to the microwave region. And that stretching fits exactly with the time of the universe. So after these results were obtained, just about every physicist believes now that, it's now bedrock science that the universe started at a point, just like Lemaitre said. There are a few diehards, but there's always a lunatic fringe there. Now, when creation didn't just produce matter energy, it also produced space, as I said. So before creation, there was no space. Now, I can't imagine what life would be if there's nothing to put things into. Okay, but there was no space. Also, if that's difficult enough, there was also no time. Time started at that point. Before that, there was no time. That's what science says, right? And it fits well with our understanding that God is out of time. Being out of time, he knows, it's like looking at a movie. If I give you a DVD, you can look at the movie at any time you want. So God can look at past, present, future all the time. So he knows all time. It fits very well with understanding that God knows all time. I can go into that further, but I'll continue with the science. Now, I'm going to show you something that's really remarkable. St. Augustine, in the 3rd and the 4th and 5th century, his book, The City of God, has two very remarkable quotes. I'll read them to you. There was no such thing as time before the universe was made. Undoubtedly, the world was made not in time, but together with time. Now, at that time, we didn't even know what atoms were. It's flabbergasting. And then the second quote, of course, there is mention in the beginning that light was made by the word of God. It may mean that that's the light from which the sun was afterward kindled. And that's exactly what happened. That energy, that light energy, eventually formed matter, formed the sun, and the fusion, the nuclear fusion of the sun produced that energy to us. So how does he know that? I don't know. But it's I don't know. It may have been very close to, may have gotten for the Lord. I don't know. But I thought to bring that up because I'm just amazed by that. Now, in addition to what I've said, creation produced also the laws of the universe. They didn't exist before the day of creation. And there are a variety of things that are obvious. Of course, the universe is expanding, obviously, because the laws said that it had to expand, and so forth. But there are many things about that we know about physics that are exactly the parameters are exactly what you need for the universe to self-assemble and eventually produce planets and produce us. This is called fine-tuning, and this is sometimes it's ridiculed, but in fact this is bedrock science. Scientists agree with that these are fine-tuned. For example, and there are a variety of things. What I mean by that, for example, is the mass of particles, the strength between negative charges and positive charges, the strength of gravity. All those are described as numbers. And those numbers have to be just right for the universe that we know of for us to exist. And as an example, for example, if you take the gravitational constant, we give you the strength of gravity. If that was a little stronger, the stars would burn out very quickly, and you wouldn't have enough time to have life evolved. And if it was weaker, you wouldn't get matter, you wouldn't get stars. It would just be, we wouldn't have the universe we have. Similarly, with the force between negative and positive charges, called the electromagnetic force, I'm pointing to this, but I'm not pointing up there. A slight difference in that the strength of that force would result in no atoms being present. You have no atoms, you can't have life. And so on. There are a variety of parameters. I'm just giving just a few parameters in physics. And there's no rhyme or reason as to why they should be what they are. And scientists are trying to figure out if there's a reason, but so far there's no reason. It's as if God had a machine with all the little dials. He set the dials all correctly, and the universe works. I'm going to give you an example of one of them concretely because I find it amazing. And it has to do with nuclei, the formation of elements. This is a drawing of an atom, helium atom. By the way, atoms don't have electrons going around them like satellites. That's not true. The electrons form a cloud. Okay? And within that big cloud, there's a very, very tiny nucleus. And that's expanded greatly. So the reason why things seem solid is because the electron clouds in this surface repel the electron clouds in my hand. If that weren't the case, our hand would go right through, and we would end up in the middle of the Earth because we have nothing to support us. So what we think is solid is in fact electron clouds. About 1,000 trillion of the volume is electron clouds, and the rest is a nucleus that's very tiny. Okay, that's what matter is. So if you think matter makes it real, I doubt it. That's just basically science for you. Now, so when I'm talking about electrons, about elements formed, and at the very beginning, when particles are being formed, the particles that were formed were protons and neutrons. Protons are positive, neutrons are neutral, and they were formed very early. And hydrogen here is just one proton in the nucleus, so it's very simple. Hydrogen was formed right away. And then you have to go to other elements. So when a neutron binds to a hydrogen, which is very easy, you form heavy hydrogen called deuterium. Heavy hydrogen that's used in trying to get nuclear fusion, for example. Now, the next step, to get the second element, helium, two deuteriums come together, and that works very well. And deuterium and hydrogen are what fueled our sun. This production of helium from hydrogen produces all this energy from the sun. Once you get to helium, there's a problem. When two helium atoms collide, nuclei collide, they bounce off. They don't stick together. They only stick together for a very, very, very short time. So that doesn't work. And helium with a proton bound to it doesn't stick either. In fact, there are no atoms that have five particles making up. That doesn't exist in an unstable state. So how do you go from having two elements to having more elements? You can't have life with two gases, right? You can have a sun, you can have energy, but you won't have a rocky object, and you can't have life. So what actually happens is, and we understand now, is that when two helium nuclei bounce together, they stick together for 100 millionth of a billionth of a second, 10 to the minus 27 seconds, and then they fall apart. Now, if during that time another helium hits it, they come together and form carbon. So the third element that was produced is carbon, which is actually element number 6. Now, for that to happen, that helium temporary structure has to have the right vibration, the right oscillations, very much like a tuning fork. Hit a tuning fork, you have a particular oscillation. When nuclei have the same oscillation, it's called an energy. And the energy has to be exactly, well, very close to 7.66 million volts per electron. A lot of energy. And when that happens, carbon is formed. And the carbon that we have is because of that. Now, if that energy was slightly off by 2%, either more greater or less, it would just bounce off, or we'd have no carbon. No carbon, no life. And not only that, if you can't make carbon, you can't make any of the other elements. So you're stuck with two gases, right? You have a dead universe. So this is just one example of the fine-tuning of the universe, very fine-tuning of the universe. And there's no reason for it to be at that energy. There isn't. Why is it like that? My suspicion is it's like that because the Lord wants us to know that this is fine-tuned, that He exists. Now, all these studies have come about because of what Lemaitre discovered. Discovering that the universe had the beginning, then people asked, so how are the elements formed? All the research came out of realizing that there's something interesting to learn about, and this is one of the results of those studies. Now, one thing you may not have heard also is that God designed the universe to eventually become lifeless. It'll take a long time, okay? Don't worry about that. It'll take a long, long time. But it's designed to be lifeless. And it's called, in scientific, it's called heat death. Why is that the case? It turns out that information was actually known long before the universe was known to have a beginning. It's called thermodynamics. Now, that sounds like a difficult term, but in fact, it's very simple. It's just a study of how energy can be changed from one form to another. Carnot, for example, observed that when they made cannons out of bronze, they were drilling the hole of the cannon, and when they drilled the hole, the cannon became very hot. You realize the energy used to drill it was converted into heat. Energy is converted to from one form to another. That's a study of thermodynamics. And there are two laws. There are three laws, actually. I'll talk about two. Well, the first law is that energy is conserved. You can't make energy or take it away. Turns out that's not quite right. With nuclear reactions, we know that matter can be made into energy and energy can be made into matter. But matter energy is conserved everywhere in the universe. It started at a certain amount, and it will be the same, as far as we know, indefinitely. Now, the second law is the problem. The second law says that energy becomes less available every time it's used. My speaking to you today results in some energy being converted from usable energy to non-usable energy. Walking around, thinking, everything we do, they're walking around, they're using up usable energy. Fortunately, you started with a lot of energy to begin with. It's like starting with a wind-up toy. You wind up toy, and it moves around, eventually it runs out of energy and it stops. But the same thing here, the energy is converted to heat. And when all is converted to heat, you have no energy. And that's the same everywhere in the universe. The universe is running down very slowly, okay? To me, it's a message that says, this is not permanent, okay? The science fiction idea is that, well, the sun runs out, we go to another planet somewhere, and eventually our culture will continue. Well, we can, but eventually it will not. Eventually, all information will be lost, all life will be lost, and if just thinking about that, if you don't believe in God, it's a very frightening thought, that the whole thing is meaningless. And when you think that, when you know what the purpose of life is, to know, love, and serve God, then it means there's no problem. So, and also, this also means that you can't make a perpetual motion machine. People have tried. You can't make it because every time anything moves, it will run out of usable energy and become non-usable. So these laws of thermodynamics have been tested and tested, and they're probably the most reliable thing in science that we know of. Okay, so the universe is a one-way direction. And in fact, knowing that energy is being consumed, you think that back in the 19th century, you'd say, well, the universe must have started at a point, or start somewhere, because we're always using up energy. But apparently, no scientist, at least nobody has recorded the idea that the universe must have a beginning, because it was just too difficult a step. Even the evidence is there, but scientists are like everybody else. They have foibles like everybody else. Anyway, one thing I want to also address is why the universe is so big when our planet seems to be so small. And this is the pale blue dot that was popularized by Carl Sagan. This is a picture of our beautiful planet from Voyager 1 back in 1991, looking back at the planet as Voyager is going away. Very small compared to the universe being enormous. So the question is, why is the universe so big, and was it made for us? Well, the second part of the question I probably can't address, but the size of the universe is related to its age as the universe expands. And if the universe was smaller, say, the Earth is 8,000 miles in diameter. Let's make the universe 1,000,000 miles. That's a smaller universe. Well, it would die in a few seconds. It would recollapse in a few seconds, and it's not very useful. What would happen in a few seconds? Even if you make it bigger, like the size of a galaxy, it would end in about a few 100,000 years, and it took about 3.5 billion years to go from the single cell to complicated life. So nothing much would happen at that time scale. By the way, the size of our galaxy is about 100,000 light years in diameter. Each light year is 6 trillion miles, so we're talking about 600,000 trillion miles for just our galaxy. Now, there are, as I said, it's a much bigger universe. So the point is, the universe has to be this big with the laws that God came up with, started with, so that we could exist on this planet. That doesn't mean there aren't other planets somewhere that may have life. We don't know that, even though, I'm not going to take too much time here, even though there are a lot we know now that the Earth is a very special place. In fact, of the 1,000 or so planets that NASA has, or scientists have detected, none of them have the conditions that will support our life here on this planet. If the Earth is bigger, gravity would be greater, and it would be okay for bacteria, but any large life forms will be crushed by gravity. Okay? Remember, the volume goes up as a cube of the radius. So if you double the size of the Earth in radius, it's 8 times the gravity. And the gravity is very important. In fact, you can calculate from first principles, without knowing anything, how big an object can be with this gravity field before it falls apart, because of the bonds between the molecules that exist. So that's one of the limitations, but other things are important. Of course, we know that the Earth is in the Goldilocks zone, not too hot, not too cold, but at the same time, the Goldilocks zone can exist very close to the star, as some of the planets have been discovered. And if they're very close to the star, gravity would result in the planet not rotating, like Mercury. It doesn't rotate. One side always faces the sun, the other side faces space. And so one side is terribly hot, the other side is terribly cold. In addition, if it's that close to the sun, the radiation from nuclear reaction would destroy all life anyway. And we're lucky, we would also have the same problem, but fortunately we have a magnetic field that deflects most of the heavy radiation away, so we're not going to be sterilized by our own sun. The moon, the large moon, which is unusual, stabilizes the motion of the Earth so it doesn't roll around, and we have a north and a south. We don't have the Earth going all over the place. We also have large planets that pick up some of the asteroids that would hit us by sweeping that area. The solar system is located in a part of the galaxy between galaxy arms, so there aren't a lot of stars nearby. Where there are a lot of stars, a lot of radiation, and there can't be any life, at least life as we know it. So we're in a very special planet. Doesn't mean it's unique. As I said, there are a lot of stars out there, but we're in a very special place, and it's not obvious that we may indeed be the only planet with life, but we don't know. I'm gonna end this by simply summarizing that we are now at a point in our knowledge of science, And I didn't get into biology, for example. That's very difficult to present in a short period of time, how complex even the simplest cell is. And our understanding just about 50 years ago was totally wrong. Even the simplest cell is extremely complicated in order for it to be alive. And by the way, we have no idea of how life came from non-life. Anybody will tell you that they have an idea, that's great, but it's not true. No, but there really isn't. And all we can do is tinker with life that already exists. So what I was going to say is that the more we learn about science, the more we realize how complex everything is, and how critical it is that the universe be exactly the way it is, and not any different. And that says that there was a wisdom that created the universe, and that wisdom is God. So frankly, I would say that someone who's thought about these concepts, it seems irrational not to believe in God. You may not believe in Christianity, but you have to believe there is a God. So I'll stop there. Questions, please. Thank you.
So just today, on the radio, they were saying how, like in 15 billion years, we are going to stop expanding. We're going to stop
Okay, that's interesting. I didn't know that.
It's just new,
because
brand new thing they came up with.
Yeah,
it's true. But it seems like it makes sense with what you're saying, because eventually the energy will run out, right?
Well, we don't know why the universe is expanding to begin with. It's called dark energy, and the last time I looked, they said that it would be accelerating, but these things change. So interesting. I'll have to look into that. We don't really know what caused it to expand. What caused the space to expand? Remember, space is expanding. Okay, and being and stars and planets are in a certain location in space, and space expands. It's like having a grid. You expand the grid, and they get farther away. And we can talk about dark energy. To know what it is, you just give it a name, and that's scientific. It sounds scientifically good, right? And the fact that if it's slowing down, why is it slowing down now? I have no idea. But thank you for sharing that. Yeah, go ahead.
I have a tough question for you, Dr. Marco.
Okay.
What do you think how do you think science would explain the soul? Would it be a form of energy?
Okay. Thank you. That's a very good question. It wasn't. It wasn't planted, but
Dr. Marco's wife.
it wasn't planted. Okay, but I'd like to address that. Anything that was created in this universe is destined to end somehow. Okay, and when people say, I wish I could see God, I would say if you see God, it's not God, because all you can see is light coming from that object. That light has to be produced by molecules that have that particular energy difference that produces that light, or reflected from the so when God displays himself, he does it in an unusual way. Like to Moses, a burning bush. God is not fire. God is not a bush. But he has to communicate with us to show us that he exists. To Elijah, it was just a sound, a tiny sound. The vibration of air that makes sound is not God. He's using us to communicate with us because we can't detect anything. Our instruments can't detect anything that's not created. We're very limited in what we can detect. So to say that I can't see an angel doesn't mean the angel is not there. In fact, the analogy would be, you look at a radio, you can tune to a right frequency and you get the right particular station. The other stations are still there. You can't detect them because you're not tuned to them. So you can have a soul here, but we can't detect it because our eyes can only detect certain light frequencies. Our sound can only detect these waves from of the air. When we touch, we feel electron clouds. we're very limited in what we can detect. And to speculate, so whatever God is, we don't know what that is. It cannot be created. He created things. It cannot be created material. So my belief is that when the right animal evolved, as it says in Genesis, God put in that animal an eternal soul. And C.S. Lewis says, I have no soul. I am a soul. I have a body. So my idea is, and it's not unique to me, is that we are fundamentally a soul. We are operating in this reality through this body. Now, eventually, we'll have a glorified body, and God and Christ with a glorified body goes right through walls, as is written in the Bible. This is not a body made of the matter in this universe. Okay? This is something else which we can't measure, we can't do this because we're limited in what we have. So that's why we need God to reveal himself to us. We can deduce that it must be a God, but God has to tell us what we need to know. And of course, he told us that eye has not seen, ear has not heard what God is ready for those who love him.
So you talked about, am I too close? You talked about the Big Bang Theory.
Yes.
Could you relate that to the immovable mover? And that's a St. Thomas Aquinas theory.
Right. Well, I think that, okay. So the Big Bang, the term Big Bang, the term Big Bang was actually coined by a scientist named Hoyle to ridicule Lemaitre, to ridicule that his ideas were stupid. But that term has remained. Probably is because scientists don't want to talk about creation. Because then if you're religious, you tend to be discarded. So they talk, the Big Bang is still, in fact, it's kind of ridiculous because it wasn't a bang. If it's a bang, we're still banging. I mean, it's an expansion that continues and continues. It's not an explosion at one point in time and that's on. It's a continuous expansion. So the term is used, and so I just think it's the same as creation. I would like to simply use the term, this is a point of creation. And then the universe does what it does because it was built into, because God specified what it's supposed to do, how it's supposed to act, how everything is supposed to interact, how energy can self-assemble to form particles, and how these particles can self-assemble to form atoms, and then molecules, and then life. It just, an analogy, let me just say this quickly. If you look at a modern factory that makes cars, you'll see the robots making cars, right? Are the robots making cars, or is the engineer who programmed the robots making cars, right? If you use a screwdriver, is the screwdriver turning the screw, or is your hand turning the screw? Okay? God doesn't have to create individual objects. I mean, infinite wisdom. He can just make it such that they'll come to be, right? Why does he have to do it individually? I mean, if we can do things remotely, we who have a tiny amount of wisdom, to me, it's if you just put the right conditions, which are amazing, then everything takes place. And of course, miracles are there because God can interfere. And that's a perfect proof that God exists, right? If you change the laws of physics locally, that's not possible. In fact, all the miracles that Christ did, nobody can do this today, right? I mean, it's just impossible because they're miracles, because they violate the laws of physics. They violate the laws of the universe. And therefore, there's proof It's a priori proof that Christ is God.
The universe has a finite space or an area.
Yes, it's exactly right. That's true.
So what happens when you go to the outer limits
There's
of
no
the
other.
universe? Do you
There,
hit a wall? Do you fall
there-
off
there-
a cliff?
no, no.
Do you meet God? What, you know?
there is no outer limit, because if you were to go fast enough, you go back to where you started. Okay? There is, in other words, remember, what's expanding is space in 4 dimensions, and so there's nothing beyond that. There is not. I mean, it's not. There's no empty. Not that it's empty. There is nothing. Before creation, there was nothing except. In fact, okay, I'll throw this out. Before creation, there was God, and that was it. Nothing else is because the only thing that really exists is God. We are created. God said His name is I am who am. I've always thought that was weird, but in fact, He's just saying, I am the only thing that exists. You were all created. Okay? And in my opinion, the universe is within God. That's why God is everywhere. We wonder, as a kid, how can God be everywhere? How do you know? Well, we are within God. They say, well, how can God be that big? Hey, size is a created thing. Before the universe, there was no such thing as size, as space, or time. This is what we experience because we live in this reality. I know this is wild, but this is reality. This is what it is.
Another question.
I'm going to ask you an opinion instead of a scientific fact. So I do science for a living too. Everything you've said to me is patently obvious. So can you explain why secular scientists are so vehement in denying it?
Thank you. That's okay. There are probably a lot of reasons. Okay, there are a lot of reasons. One of the reasons is that most scientists are very specialized in what they know. Back in Newton's time, scientists knew everything because there wasn't a whole lot to know, right? But now, you talk to an endocrinologist, they know endocrinology. You talk to a cell biologist, they'll know something about the mitochondria very well, but they won't know very much about nucleolus or what I'm saying. You know something about it, but you really focus and specialize. So to think about, and they may not have thought too much about it, and also that there's a penalty to be too religious. I can tell you personally that I was interviewed for a deanship, and once they realized that I'm a Catholic, that was not a good idea. Okay, so what else? There's also that's all I can think of. There are a lot of reasons. There's social pressure. There were probably at an older time where that wasn't a big problem, but now the other another speculation is that because of where we are with what we know, the devil has to work much harder to make life difficult for us. If you're too close to the truth, you're going to be attacked. They say, you know you're over the target if you get flack, right?
Okay, one last question over here. Let me bring you the microphone, okay?
I think I can get my
Sure.
agenda out there. No,
Go ahead.
so maybe a follow-on comment to what you just said, sir. Back to your slide on fine-tuning. God had to fine-tune values to make matter and life possible.
Mm-hmm.
As I'm sure you know, there are a lot of scientists, or maybe they're not scientists, theoretical physicists, who have, and maybe they're an instrument of Satan, I don't know. But who have posited the idea of the multiverse.
Oh, yes.
You know, that different universes pop
Sure,
up.
sure,
and bubble
sure,
up
sure,
around.
sure.
And so it's just, because it's infinite,
Mm-hmm.
it's obvious or ultimately going to be so that some universe will pop up with the right values, and we just happen to be lucky enough
Okay.
to be in it. Now,
Thank you.
to me,
Yeah,
believing in that takes as much of a leap of faith.
much more, much more. Yeah, thank you for raising that. That's very important. It can't be argued that the universe is not fine-tuned. It is fine-tuned. The people don't, so the statement is, well, if it wasn't fine-tuned, we wouldn't be here to ask the question, therefore it must have been fine-tuned, right? Okay, but that's a circular reasoning that doesn't really help at all. So why is it perfectly fine-tuned? Well, one solution that's stated is that there are an infinite number of parallel universes. They all have different settings, and we happen to be in the right one, right? Now, in science, a good theory is the best theory is the one that has fewer non-measurable parameters. Now, you take the God exists, we can measure God, that's one unmeasurable parameter. Once you accept that, everything makes sense. It's like little pieces of puzzles. You have the key piece and everything comes together. Now, the alternative is a theory that has an infinite number of non-measurable parameters, and that's supposed to be a better theory. I have to say that. That's not a good theory. If in any other context, that would be disregarded. Now, the other thing I want to say is that we, scientists and everybody, has a very creative mind. They can come up with all kinds of interesting ideas. And you just watch a science fiction movie, all kinds of things that some are possible, some are not possible. And especially in physics, it's been stated by people who are, I'm not a physicist, I'm a biophysicist, that if a theoretical physicist is not wrong 80% of the time, they're not doing novel work. So the idea, you have a lot of ideas and you pick out the one that the experiments say is correct. Unfortunately, you can't do experiments on universes that you can't detect because they don't exist. So you come up with this idea, it's not testable, and in any other context they would say, well, that's an interesting idea, but since it's not testable, I'm not going to even consider it. But since the alternative is to propose God, and that's often taboo in science, then even a crazy idea is considered possible. Now, there's another idea that this happens to be a universe that's budding. There's something, and we happen to be a bud that exists in the universe. But again, this is an idea that you can't test, you can't measure. It's okay. People should think about other things and see what happens. But at this point, with what we know right now, with what's shown experimentally, the whole idea is, well, normally I would think about science as simply knowledge. But today, when you talk about science, it's restricted to science that can be proved experimentally. I think the knowledge that God gave us is knowledge and is part of understanding reality. But if you simply limit it to what you can measure experimentally, then some of these ideas would be excluded because you can't measure them. So I can come up with all kinds of crazy things, and so what? That means nothing. The parameter, we all have a certain hierarchy of knowledge, and we throw away things that don't fit. And when something comes in that fits better, then we accept it. And we build up this edifice of knowledge. And so based on what we know, the best idea is what I described. I didn't describe the other ideas. That there was nothing, there was only God to begin with, and God created it, and that's what we are, that's what's there. And you look at the universe, you find it fits with a very intelligent design. It fits with the fact that the universe is going to be eventually dead. And our purpose is we're being tested. This is, I mean, I wish we had a midterm so we know how well we're doing. You know, give me a chance to know how well I'm doing. But it's what it is.